Yeah. In this saponification reaction, what happened? Triglyceride breakdown. Triglyceride breakdown mean it's three ester bonds. You know, triglyceride has three ester bonds because it is produced by one glycerol molecule and three fatty acid, right? It has three ester bonds. When it is break down three ester bonds, what happened? It is this glycerol and fatty acid separate this glycerol and fatty acid. Then these sodium plus ions react with combine with fatty acid. That's why we called as sodium stearate, mean long R long carbon chain of fatty acid with sodium fatty acid, long carbon chain of sodium fatty acid, right? That's a sodium stearate or so. That's a so. That's a so. This is so. Finally, this remain OH react with this breakdown part and it is produced CH2OH, CHOH, CH2OH. What is the name? Glycerol that we can use in normal cosmetic production, different creams, girls use Eva. And toothpaste, it's just like a gel. Gel වගේ හදන්න use කරන්න පුළුවන්. I got clear? Any doubt? Okay, any doubt? Sharon? Tanya? Any doubt? Okay. Do you remember soap production steps? What we doing? First, heat in the oil. Heat in the oil. Just revising. Heat the triglyceride. That means oil, coconut oil or whatever oil. Heat. Then after, add 50%. 50% sodium hydroxide and 50% water solution into the 50% sodium hydroxide plus 50% water solution into the heated triglyceride. Then mixing very well. Mixing until complete the saponification reaction. Mixing. Okay, right? I will show you now this practical mixing. Then we can feel some increase the thickness, right? That means it's complete the saponification reaction. Complete the saponification reaction. After that, the cleaning process. After that, we can separate sodium hydroxide and soap. Normally, sodium hydroxide, glycerol and soap. Okay, in the separation process, the very important step is salting. Do you remember? Salting. Because but normally, naturally, this soap and glycerol, soap is less dense than glycerol. Glycerol is a high density. Therefore, naturally, it's make as a lower layer. Make maybe separate කරාමන්නේ. This is a glycerol, and above the glycerol layer, it is producing soap layer. Normally, that we call soap floating on the glycerol. Soap floating on the glycerol. But we can't we can't see clearly this separation layer. Then what we can do? We can add salt. We can add enough amount of salt and refrigerate. Refrigerate means rotating with high RPM. With high RPM, we can rotate this. We can rotate, right? Then what happens? We can clearly separate this glycerol and soap layer. Then we can pump the amount of soap we can pump out. The soap here we can pump out. Then what is the next step? Again add salt. Remain glycerol amount. We can add salt again and again refrigerate. Then if there are any remain soap particle, again we can separate and pump out to the container or separate container. Right? Matakai, do you remember? Okay, after that, Tanya, what is the next step? We have to purify that, okay? We have to purify that. We have to purify that. Okay, what are the impurities contained in this separated soap? Now glycerol is done. Glycerol is separated. Then මොනවද තියෙන්න පුළුවන්? Yes, the main thing remains sodium hydroxide. Remain caustic soda that can have it with separated soap. Okay, how to remove this separate? How to remove this remain sodium hydroxide? Quickly. How to remove? How to remove? That we called as neutralizing, right? We can't remove that. We can't remove, but we can add very weak acid. Samani මොන acid එකද අපි ගන්නවා කිව්වේ? Tanya? Very good. Others? Normally, what is acid? Yes, very good. Citric acid we can use. Citric or any acid type we can use. But the thing is the expensive, the cost of the thing. That's why we use very weak acid type. This is citric acid. Citric acid. We can add enough citric acid until we can measure pH value and until neutralizing. Neutralizing means normally 6.5 to 7.5. It's okay. It is not damage to our skin. If it is contain unreacted sodium hydroxide without neutralize, it is damage to our skin and eye. Eye mainly. Accelerator. Okay. After that, we can add filling materials. I told as filling materials, we can use sodium carbonate and silica. Silica means just sand. Sand. We can grind and add as a filling materials. After that, add coloring agents and smell agents, smells, fragrance, and packing and marketing, right? Packing and marketing. Okay, I will show you how to prepare a soap sample in laboratory level. අපේ ස්ටෙප්ස් එක පොඩි වෙනස්කම් තියෙන්න පුළුවන් මම ඒක කියන්නම් හරිද in this beaker and okay they are the caustic soda normal same as salt just yellow color particles not yellow white color particles. This sodium hydroxide. These are sodium hydroxide flakes. I have taken 15 grams sodium hydroxide, caustic soda. Here, solution of sodium hydroxide. Okay, this is a water. That is 50%. 15 grams sodium hydroxide solution for preparation of soap. Yeah, 15 gram, and they have got 15 milliliter. That's a ratio, right? That's why we call as 50% sodium hydroxide caustic soda solution. Water and caustic soda. Exothermic reaction. Milky solution is formed. Yeah. The now sodium hydroxide solution. One reactant is ready. First reaction is ready. Now the 15 grams sodium hydroxide solution will test whether it's based. They show in the pH value. Yeah, let's see. Red convert to blue. Then what's the meaning? It's highly base, right? If you use blue litmus, it no any color change. See, no any color change. That means highly base. No change. See? No change. Highly base. Along with this, it's quite hot, so we'll hold it here. Along. Yeah, this. That one also important, right? No change in color. Means this solution is designated. Along with this, normally this water and sodium hydroxide reaction, is it exothermic or endothermic? Water dissolve, sodium hydroxide, caustic soda dissolve in water. Is it exothermic or endothermic? Sarmia. Water sodium hydroxide dissolved in water. Exothermic or endothermic? In thermochemistry lesson we discussed, right? Fatima? Sodium hydroxide means caustic soda dissolved in water. Exothermic or endothermic? Good, Sarmia. Exothermic, because sodium hydroxide is powerful base. Base water, all reactions are exothermic, right? It is given sodium. It's an exothermic reaction. Then we can feel some heat generate, right?
Along with it, we use 60 ml coconut oil.
Yeah, this is a coconut oil. And this triglyceride.
15 grams of salt.
Yeah.
Salt solution is also
salt solution, right?
Needed.
Salt solution.
Water.
For salting process.
Salt. Sodium chloride. Now here is 15 grams sodium hydroxide solution. This is 60 ml coconut oil.
Okay, this laboratory production can be changed with our discussion. The difference is in this laboratory experiment they mixing first these glycerol and triglyceride and yala mix karla tama heat karan. But in our syllabus given, just first heat the triglyceride and when it is heated at sodium hydroxide solution, right? Caustic soda solution. That's only difference. Don't think about that.
Water in which 15 grams.
Remember the Newt given steps.
Now we'll add this sodium hydroxide solution in oil.
Last week we discussed first heat the triglyceride and add sodium hydroxide.
And then we pour this hot. So
yeah,
you hold it carefully. And while pouring, you have to stir the solution.
Yeah, stir the solution.
Now it's stirring. This mixture is ready. Oil and sodium hydroxide.
Okay, now you can see the saponification is happening. Increase the thickness. To accelerate this process, now they are heating. Heat karla, mix karla, heat karat, the same thing. The saponification is take place, right?
For heating, use this tripod.
That we call as tripod, right?
With a little bit, I'll keep it on this corks. It's falling a little short, so I'm giving it a little height. And then this is
they call it Bunsen burner, and this is a net, iron net.
Tripod. And then we put this spirit lamp under this light off, like this one. Put the solution for heating for 10 to 12 minutes. So while heating, we need to remember to stir the solution.
Yeah, we have to stir now. Why we need to stir?
Continuously.
Why we need to mix this? Last week I explained. Because sodium hydroxide aqueous solution is a polar solution, right? But triglyceride is non-polar solvent. It's completely different layers, not mixing. For collide reactant molecule each other, for this efficient saponification reaction, we have to mix well. For evenly mix this solution for proper reaction take place. Otherwise, some parts of these layers not reacted due to not contact this triglyceride and sodium hydroxide. Therefore, evenly distribute and evenly stir this solution is compulsory for efficient reaction of saponification, right? The reason this non-polar solvent and polar solvent, it is not mixing. That's why we need to contact. We need to contact this reactant molecule each other by even mixing.
Stir the solution for 10 to 12 minutes. Take care not to boil over this solution, as we have taken a large beaker. So there is no possibility.
Okay, now you can see the thickness is increasing, right? Increasing the thickness. That means saponification is done.
Boiled solution is ready. We have boiled it for 10 to 12 minutes. And now we'll add this solution of sodium chloride.
Yeah, sodium chloride, salt.
That is common salt. Then this,
yeah, salts added into this solution.
And we'll stir it continuously.
What's the purpose of adding salt? To separate two layers. To separate two layers, right?
Thus, we have boiled sodium hydroxide and oil mixture.
With salt, the salt may glycerol, the produced glycerol density is increasing because salt not dissolved in soap, salt only dissolved in aqueous region, aqueous parts, lower glycerol part. Therefore, increase the density. Therefore, the soap is low density particle. Therefore, we can separate glycerol and soap separately by this adding salt, salting step.
And then mix solution of salt. We'll stir it. We'll let it rest for some time.
Yeah, now you can see clearly separate, right? This is a glycerol. This is a glycerol and this is a soap.
Yeah.
The dark white color is a soap. Yeah, it's clearly separating, right? If you want to accelerate the separation, we can centrifugate. Remember, centrifugate. Yeah. If we keep rest, we have to wait 30 to 40 minutes. But if we centrifugate, we can within few seconds, we can separate, right?
This chemical process, the soap floats on the switcher and it has not thick because we let it settle down for some time. Now we'll separate this soap in a mold.
Yeah, this is a soap. Now they doing in simple way. Normally in that industrially we can use pump. In large scale production we can pump. After separation we can pump into soap, separated soap we can pump into another container, right? But they are doing in laboratory level very simple. Okay, this is soap. It is a okay, when it is cooling, you can see it is converted to solid. Okay, this is all. Just sample, right?
Thus we have prepared this soap powder. This is what is soap and it is a sodium salt.
Okay, can we use this for our skin? මේ විදිහටම use කරන්න පුළුවන්ද? They missed one very important step. They missed one very important step, right? What is this? They missed one important step. The neutralization, rust. the neutralization. They didn't do neutralization. Then it's contain unreacted sodium hydroxide. This unreacted sodium hydroxide means caustic soda. They are highly base compound. They are very toxic to our skin and eyes. And this is the sample. In industrial production, we add filling materials and coloring and fragrance as well, right? Okay, that's the soap production. Do you have any doubt or any question? If you have, you can ask about soap production now. Okay, that's the end of soap production. If you have any doubt, please ask now quickly. We don't have time because today we have another very important lesson, biodiesel production. Any doubt? Sarmia? Tania, Dihni? Fatima? Sharon? Ramka? Great. Okay, let's move into our second production process, biodiesel production. Our second production process, biodiesel production. Now you all collect tubes, right? Raise hand. You all collect tubes, right? Mama? Yeah. Hari. Hari. Hamatam tena nathika or hari na? Raise hand. If anyone don't have tube. No, ne? Yeah. Everyone has tube. Okay. Go to page number. Dihini, I got. Yes, good. Go to page number. Sharon, Hambunath. Go to page number 40. Page number 40. The biodiesel production. Okay. Now, before start biodiesel production, what is the main issue? What is the main problem nowadays in the world? The main problem is energy crisis. Why it's coming? Energy crisis, like countries like us, normal tropical countries. We have a lot of energy resources, right? We have entire every day we have good energy, solar system. We have sunlight every day. Every day we have solar system and we have solar energy, and we have two wind sources, not that we called as northeast monsoon and southwest. Sorry, yeah, correct, right? Southwest monsoon and northeast monsoon. We have two monsoon periods. and we have enough wind resources, and as well as we are island, then we have hydropower. We have a lot of rivers and waterfalls, everything. And around the country we have sea. Then we can get sea wave energy, right? Then we have a lot of energy sources. But still, we are producing more than 50% electricity from diesel and naphtha. Naphtha is a byproduct of petroleum production. Naphtha and diesel are the main that we call as thermal energy converted into electric energy. But we have a lot of resources. Normally, hydropower, water, using water, electricity generation in Sri Lanka, it is sometimes 40 to 44%. The wind power generation 1 to 3% wagi. The whole amount 44 plus 3, 47, 52, 53% produced by thermal energy. Thermal energy mean thermo power plants. Thermal power plants mean using diesel and naphtha. Diesel and naphtha. Burning in the burning process. Sometimes we using what we called the naphtha and diesel, and another one we can use. I can't remember the name. Coal. Gallanguruke, coal. Okay, they all are non-renewable resources. Coal, naphtha, and diesel, they are the main energy, electricity produce things, resources in Sri Lanka. Not Sri Lanka, other countries as well. But they all non-renewable. Why we call they are non-renewable? Why we call they are non-renewable? What's the reason? Do you know how to produce these all coal, naphtha and biodiesel all produced by crude oil? Crude oil means fossil fuels. All produced by fossil fuels. Do you know how to produce fossil fuels? Any idea? Fossil fuels. Udanya, how to produce fossil fuels? How to produce fossil fuels? Yes, very good. The fossil fuels are made by the digestion of dead animal and plant material more than million years. Normal production process, it takes more than million years, right? Normally, think this is our earth. On the surface, plant material and animal dead bodies accumulate in the ground layers, and they accumulate means collecting into like drones, right? This energy accumulate in whatever areas, then we can extract these fossil fuels like crude oil and coals. They are different types. Everyone contain this dead animal, plant and dead plant and dead animal digestion particles, digestion energy. This animal and plant energy are the stored. Energy stored. Normally, it's a type of chemical energy. It's a chemical energy. Okay, after purification, that we can burn this. This is chemical energy. Normally, petrol, diesel, everyone contain chemical energy, right? Chemical energy. This chemical energy convert into heat energy or thermal energy in the burning. In the burning. In the burning. After that we can use to electric energy production. Electric energy production, if you got vehicle, that we can convert to mechanical energy. Mechanical energy can convert. This heat energy convert into mechanical energy, that we reciprocal motion of the piston, right? The main heat energy, the chemical energy convert into heat energy, and it's convert into different energy types, and that we can use for our purposes. But why we call these fossil fuels, fossil energy, fossil resources, why they call non-renewable? What is the reason? But they are always producing, always adding dead animal and plant material in the soil, and they accumulate. Why they called it is a non-renewable source? Dini, any idea why we call it is non-renewable? Why we call it as non-renewable source? Very good. No. See, Kabir, it's wrong. See, normally we using that we call as consumption, fossil fuels consumption, like this. This is story. Fossil fuels consumption, it has a relationship. Very good, Sharon. Okay, that's the thing. Actually, it is naturally producing. If we call it is not an artificial thing, it is naturally producing. Fossil fuels naturally producing. Mebala, think it is fossil fuel. Fossil fuel. Fossil fuel. Fossil fuel burning. Fossil fuel purification and burning, right? Burning. In the burning process, it is converted to heat energy and release carbon dioxide and water, mainly water vapor, carbon dioxide and water vapor plus heat, right? Then this carbon dioxide absorbed by plant, carbon dioxide and water both absorbed by plants. Plants producing foods in the photosynthesis process. They are the main photosynthesis raw material, right? The photosynthesis, in the photosynthesis process, it's producing foods, and animal also depend on these foods, and increase the population of plants and animal population increase in the earth due to this carbon dioxide and water vapors. Again, in the decomposition of plants and animals, what happened? It's again producing fossil fuels, decomposition. Then what we call, why we call Kabir, why we call is it an non-renewable source? Non-renewable, it is producing, burning, it is producing plants, and plants producing fossil fuels, no issue. Fatima, any idea? Ranga? Why it's no problem? It's no any problem. Yes. According to the consumption rate, normally how many years take for this decomposition process? It will take more than million years. More than million years. Think it is million? Million mean 10 lakhs. 10 lakhs. But nowadays, in the world, it is production rate is sometimes 1 lakh times than production rate. if it is produced one liter of fossil fuel, 1 kilogram of fossil fuel, it is produced 100,000 lakhs of fossil fuel. Are you good? The consumption rate is not aligned with the production rate. That's a problem. That's why we called as non-renewable resources, non-renewable energy resources. Fossil fuel is a non-renewable energy resource. Why? According to the consumption rate. According to the consumption rate, the production rate is minimum. Production rate is very low. That's why definitely, if we consume like in this pattern, if we consume in this rate, definitely in future day, the fossil fuel will be over, right? Think in bank account, you have 100,000 ඉතින් ලක්ෂයක් තියෙනවා 100,000 rupees. Monthly you add 10 rupees and you get 100 rupees. මේක නිකන් මේ වගේ add one, only deposit 1 rupees and only credit 100 rupees, right? What happen after some time, after some time period, your account value will be 0, right? The same thing, if the fossil fuel production rate is not equal to the consumption rate, it is the production rate is very low. That's why we call fossil fuel is a non-renewable energy source. Understood? Akash? The fossil fuel is a non-renewable energy source actually. That's why we call. Others? Amina? Understood? They are very important. Probably this time question will essay question. Asking from this part because due to current situation, right? Others, they're not right. Okay, see, the petroleum fuel are non-renewable energy source. These resources are not uniformly distributed around the world. This is another problem. This petroleum fossil fuels not uniformly distribute. That's the main problem for current problem, right? It is not uniformly distributed around the world. Since modern human civilization mainly depend on petroleum fuel. Yes, it has led to political, economical, and social issues in global. Yes. Depletion occurs when non-renewable sources are consumed faster than naturally replaced. Yes, that's the thing. Our normal consumption rate, it is very faster than the production rate. Therefore, continuous global consumption of petroleum fuel leads their gradually exhausted. Okay, it's considerable value. Okay, that's a normal world scenario, the world nature. Okay, the petroleum fuel is actually again producing fossil fuel also, but the thing is it's very slow, the production process, but our consumption rate is highly overconsumptions. We have a higher consumption rate comparatively production rate. It's sometimes 100,000 times. 100,000 times it is greater than the production time consumption rate. The Herbert is we have a special law that we call as Herbert law or Herbert theory. He is a scientist who investigate about the petroleum fuels and its consumption rate. Okay, the Herbert theory states that the depletion of non-renewable sources. It can cover the hard in a future day, whatever future day, the petroleum fuels will be depleted. That will be finished, right? That will finish. Depends on the human consumption rate, right? Human consumption rate. According, yeah, that's he explained. That's the thing he explained. That's a theory. Herbert theory he explained the current fuel production. It has a mistake. According to this theory, current fuel consumption, not production, consumption. Consumption karega? Consumption increase over time. Yes, the current fuel consumption increasing over time, and it is reached to the maximum, maximum that we call as peak consumption. Peak consumption. Then gradually decrease as resources become wait. Yeah. Due to the these resources, scarcity of these resources, it is gradually decreases. Okay, this is Herbert is a scientist who explained this theory. Okay, this very simple theory. Okay, this is a just simple graph. Okay, this is the x-axis. X-axis is the yeah. Wait. He explained these x-axis. This is a time. It should be time, and the y-axis is a consumption. That means petroleum production, right? Consumption. Petrol diesel production and consumption. He explained this graph starting from this point, and it is continuously increasing like this. The consumption pattern gradually increasing with time, and after passing this point, some point, it's gradually decrease due to the scarce resources, due to the low production, like this. Scarcity of this product. Due to scarcity, it is getting decreased like this. Okay, normally he explained 2070 is this year. Come to the maximum. 2070 is the, you don't need to mention this years, just for your knowledge. 2000, when it is come to 2070, the human petroleum consumption come to peak level. Peak level means the maximum level, and due to the scarcity of these compounds, the scarcity of these resources, then the production rate gradually decreasing. Then what humans doing? They finding more other options, other renewable options. They have to find more renewable options due to the scarcity of these resources. Scarcity. කියන්නේ අඩු වෙනවා කියන්නේ. හිග වෙනවා. Okay, please note down this graph in your tube. Yeah, due to scarcity of resources. Due to the scarcity of resources, the consumption rate decreasing. Okay, this is the Herbert theory. What he explained according to the current consumption of, according to the current consumption pattern of petroleum fuel. The petroleum fuel consumption, non-renewable resources consumption, gradually decreasing, gradually increasing, gradually increasing, and when it is come to peak due to the scarcity of resources, its consumption gradually decrease. Okay, this is the thing he explained. Fuel consumption increase over time and reach to the maximum point, then gradually decline as resources become scarce. Understood? That we call as Herbert theory. Herbert theory. Why he explained about this Herbert theory? Due to the non-renewable energy source. Non-renewable energy source means it is not producing according to our consumption rate. The consumption rate is greater than the production process. The production process is very low, but the consumption rate is very high. Complete. Sorry, it is time. Time. Understood and complete? Udanna? Yes. It's generally accepted that the depletion of petroleum fuels is approaching as they are non-renewable energy source. Actually, non-renewable, as they are non-renewable energy source, the petroleum fuel depletion. It has a depletion. It means it has a end date. The burning of petroleum fuel leads to environment problems due to the increased carbon dioxide concentration. Yes. Normally, if it is using in natural, if it is using in normal rate, the The released carbon dioxide and water vapor can absorb by plants and they can use for photosynthesis process. But in the overconsumption, what happened? In current situation, these fossil fuels overburning. Vehicles, machines, everywhere use electricity generation in Sri Lanka and other countries. It's overrate consuming, right? Due to that, what happened? The carbon dioxide release concentration increasing. Can plants absorb all carbon dioxide bond vapor? No. Therefore, lot of environmental impact like global warming, because carbon dioxide is a greenhouse gas that's absorb heat energy and retain in the environment. The burning of petroleum fuels led to environment problems due to increase of carbon dioxide concentration in the atmosphere, contributing global warming. Yes, contributing global warming. For these reasons, attention toward new renewable resources, wind energy, hydropower, increase the production of hydropower and increase the technologies of that and use solar power. Okay, due to that, humans all may always after few years later, due to the scarcity of these resources, always humans, this is a assumption. This assumption, they normally scientists think after some years, ඒ කියන්නේ තව 10 years වගේ යද්දී 10 years වගේ යද්දී due to the scarcity of these non-renewable resources, people more tend to renewable resources, more tend towards to the renewable resources because renewable resources again producing, therefore they are not depleted. For these reasons, attention towards renewable new material is increasing worldwide. Yes. As a solution of these non-renewable resources, the biodiesel is a type of renewable resources, renewable energy type, renewable fuel type. Normally, it is very difficult to use solar power, wind power for vehicles and engines, but biodiesel is a good solution for this. It's a type of fuel. It's a type of fuel that we can use for vehicles and engines. Okay, biodiesel is a good solution for these non-renewable resources. It's a renewable resource of biodiesel production. Okay, this is a biodiesel production cycle, right? Why we call it is renewable? Think this is carbon dioxide, right? Carbon dioxide. Now let's start from biodiesel. Think this is biodiesel. In the burning process of biodiesel, what are the products? Biodiesel burning, that one also produces carbon dioxide and water, right? Carbon dioxide and water. This carbon dioxide and water vapor important to produce plants. Carbon dioxide and water vapor important to produce plants. By plants, we can get methanol and triglyceride. Methanol and triglyceride. methanol and triglyceride. Methanol and triglyceride, right? After that, these methanol and triglyceride we can use to produce this biodiesel. Methanol, and remember, methanol and triglyceride are the main byproducts, main raw material, not byproduct, main raw materials for biodiesel production. Remember, methanol and triglyceride are the main raw materials for biodiesel production. Okay, now you can see it has a quick cycle. Quick cycle means not like petroleum diesel production. In biodiesel production, we can see this release carbon dioxide and H2O quickly absorbing by plants, and they convert into triglyceride and methanol. Triglyceride means oils, no? And methanol also we can produce by plants. I will show you. Then triglyceride and methanol are the main raw materials for biodiesel. Normally, to produce fossil fuels, it takes more than million years. But production of triglyceride and methanol, it takes just few months or few years. Within few years, it is producing triglyceride and methanol. That we can use for biodiesel production. Then that's why, according to consumption pattern, we can increase the production as well, because the biodiesel production is a chemical reaction. I will show you. It's a react triglyceride and methanol in a chemical chamber, reaction chamber. Therefore, according to the consumption, we can produce using triglyceride and methanol. That's why we call biodiesel production is a renewable process. I got. Please note down this. This is a biodiesel production circle. Biodiesel production circle. Okay, complete. Okay, what we discussed up to now? Okay, we discussed the fossil fuel is not a renewable resources. Why? According to the consumption pattern, the production rate is very low. The consumption pattern is very higher than the greater than the production rate. Production rate very slow, but the consumption rate great. Therefore, it is not a renewable source that we not consider as renewable source, right? But biodiesel production that use methanol and triglyceride, both natural raw materials, plant produced raw materials. And the biodiesel production process is chemical process. Therefore, according to the consumption rate that we can produce, and it is again this raw materials generating, right, by plants. I got. Therefore, biodiesel production process we called as renewable resource, renewable energy production. Any doubt up to now? This is very important lesson, right? Any doubt up to now? Any doubt up to now? Kabir, Fatima? Hi. Come to the next lesson. Okay, this is a lesson actually. Now we are going to start. Hi. Okay, same as soap production, biodiesel production chemical reaction has a special name that we called as transesterification. Transesterification, where it is given. The production of biodiesel, this chemical reaction has a specific name. It is transesterification, where it is given. It's not given, right? The main raw materials to produce biodiesel is triglyceride and methanol. Yes, now you already know. Triglyceride means just oil. It is same as soap, but now it is methanol, right? The second raw material is methanol and triglyceride. Sodium hydroxide used as a catalyst. Yes, in soap production, that's the most important thing. In soap production, sodium hydroxide, that means caustic soda, is a raw material. Okay, but in biodiesel production, sodium hydroxide, caustic soda used as a catalyst. I'll show you. I'll explain later, right? Point by point. Same as soap production, glycerol is produced in the byproduct of this process. Glycerol is produced as a byproduct. Okay, this is a story. This is a story of biodiesel production. Okay, now what is the process? That process we called as transesterification. The transesterification is a process. Transesterification. Transesterification is a process. Transesterification is a process. Transesterification is a process. Okay, what are the raw materials of transesterification reaction? Triglyceride, same as previous. CH2, oxygen, COOR, CH, oxygen, COOR. It is same as soap production, right? CH2, oxygen, COOR. This is a triglyceride, main raw material. Triglyceride. 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 Okay, next. What is the next raw material? What is the next raw material? Now it is already given. What's the next raw material? It's already given above. Udanya, what is the second raw material? It is methanol, right? Methanol. Then what is the chemical formula of methanol? What's the chemical formula of methanol? Remember, it is CH3OH. It is react with blue color. It is react with CH3OH. For balance this equation, we have to add 3. CH3OH, that means 3 methanol molecules. Methanol. Right? CH3OH, 3 molecule. Methanol. Now, the most important thing in the trans-esterification reaction, this ester bonds break down, same as saponification. Ester bonds break down. Break down these ester bonds. Then glycerol and fatty acid separated. And CH3 and OH separated. This CH3, it is same as soap production, right? Please get the idea. Very simple, right? Same as saponification reaction, the CH3 combined with fatty acid. CH3O like this. 3 biodiesel molecules produce it. And finally, this OH combined with these OH molecules combined with CH2, it's producing glycerol. CH2OH, CHOH, CH2OH. So the CH2OH, CH2OH, CHOH, sorry, CH2OH, CHOH, CH2OH, it is glycerol. It's glycerol. What's the name of this? This is a biodiesel. That we call as long chains of methyl ester. Long chain of methyl ester is a biodiesel. Understood? It is same as soap production saponification, right? I forgot. In this reaction, we have to add sodium hydroxide. Sodium hydroxide as a catalyst. It is not the raw material. Sodium hydroxide as catalyst. Okay. Understood? This is the trans-esterification reaction. The main chemical reaction of biodiesel production. If you have any doubt, you can ask now. How to break down ester bonds, everything. If you have any doubt, you can ask now. Dihini, understood? This biodiesel called as methyl ester of fatty acid. Then clearly note down Clearly note down with understand. තේරුම් අරන් ලියන්න. Okay, complete. What is the name of biodiesel production reaction? Transesterification. What's the name of soap production reaction? Saffronification. What are the raw materials of soap production? Triglyceride and caustic soda. What are the raw materials for biodiesel production? Triglyceride and methanol. Simple, right? What are the can anyone send me what are the catalysts used in soap production? What is a catalyst used in soap production? Fatima? What is a catalyst used in soap production? Kabir? What is the type of catalyst used in soap production? Dehini? Can't anyone remember? Udarnya? Anyone? Can't remember? No, Sharu. I'm asking soap production. Culling එක saponification. No. Sarmiya. No, Udarnya. Fatima, what do you think? Tanya, what do you think? Yes, Dihin. No any catalyst used in soap production. In soap production, get the idea. Very simple thing. In soap production, soap production, chemical reaction, saponification. Raw materials, triglyceride and caustic soda. Then produce sodium stearate and glycerol. That's all. No any catalyst used. Sodium chloride is not a catalyst. Sodium chloride at only for separation process. It is not a catalyst. It's not help to the chemical reaction saponification that we not consider as catalyst. Remember, in soap production, no any catalyst used. No any catalyst is used. Okay, then no any catalyst is used in soap production. But in biodiesel production, we have to use catalyst for help for this trans-esterification reaction, that is caustic soda. Remember, in the caustic soda in soap production, it is a raw material. Raw materials. In biodiesel production, caustic soda is a catalyst. Don't mix up. Okay. Then it is produced biodiesel and glycerol. Remember, soap production and biodiesel, both productions, the byproduct is a glycerol. Byproduct is a glycerol. Okay, that's the difference and similarities. Okay, any doubt up to now? Do you have any doubt up to now? Okay. Sometimes in biodiesel production, methanol requirements we can get by petroleum production as well. Petroleum production, as a byproduct of petroleum production, that means fossil fuel purification, we have a methanol extraction. Okay, if you use this petroleum extracted methanol, it is not 100% renewable source. Therefore, we have to focus into methanol produced by biological resources. Normally, do you know how to produce biomethanol? Biomethanol using Saccharomyces, type of Saccharomyces. You know the ethanol. Do you know ethanol? C2H5OH. That's ethanol. C2H5OH. It is ethanol. Ethanol. CH3OH. It is methanol. If you got this ethanol and methanol, as the appearance, they are same. Penumin saman. And smell also mostly same. But remember, ethanol is not that toxic to us. Ethanol apita bond puluwan ne tiyenne drinks or wine, beer, it's contain ethanol. Ethanol is not toxic. It is in high concentration. It can be toxic. It's burning our body cells. But methanol in very small concentration, methanol is highly toxic. Remember, even in very small concentration, very diluted one also, it is highly toxic. It's hazard material, but it is ethanol is non-toxic. Remember, normal ethanol production. Now, how to produce ethanol in beer production or whatever alcohol production? How to produce ethanol? By using Saccharomyces cerevisiae. That means fermentation process. In the fermentation process of sucrose, get sucrose solution and add yeast, Saccharomyces cerevisiae type yeast, just adding yeast and fermentate. In the fermentation process, this C6H12O6, that means glucose containing this convert into glucose, react with oxygen, not oxygen, sorry. It's convert into C2H5OH, that means ethanol, alcohol, and carbon dioxide. Ethanol and carbon dioxide in the fermentation process. Okay, if we introduce for the sucrose solution special Saccharomyces cerevisiae, specially designed Saccharomyces cerevisiae, instead of ethanol, they can convert this ethanol into methanol. They can convert this glucose solution into methanol, but it is highly toxic. Kadahari Vivoth. Yeast in the equation me? I couldn't understand. Yeast in the equation me? No, yeast is not a chemical. Yeast is a type of fungi. It's a microorganism. Saccharomyces cerevisiae. They are the factor. They are the doing this chemical reaction, fermentation reaction. Okay. याला तमा ferment करला make a convert करना in the process. Glucose, they actually this Saccharomyces cerevisiae yeast is a fungi type. This fungi type depend on glucose. They use as their energy source. As a result of this depend on this glucose, they convert glucose into ethanol and carbon dioxide. Release carbon dioxide. Understood, Amar? Okay, yeast is not a chemical, it's just a microorganism that we can discuss in our next lesson, cell structure lesson. Okay. Now, if we use specially designed, cultured microorganism, we can, instead of producing ethanol, we can convert this glucose into methanol. CH3OH. That we call as biomethanol production, but it is highly toxic. Remember, it is highly toxic. This biomethanol or whatever methanol type, the methanol chemical is highly toxic. Sometimes 2D productions 2D production can draw in 2D productions mistakenly they can produce methanol. Methanols if you drink methanol, it is highly toxic. Mariner level it's highly hazard chemical, right? Methanol produced or not, it's highly hazard. Okay, now I told you sometimes for biodiesel production, methanol collection, we can use petroleum extraction from petroleum. If you use petroleum extracted methanol, it is not 100% renewable. 100% renewable. Therefore, if we can produce biomethanol using glucose, the fermentation, microorganism fermentation of glucose solution, we can produce 100% renewable biodiesel, right? The methanol required for this process obtained from the petroleum industry. Therefore, biodiesel is not 100% renewable resources. The focus is the production of biodiesel using biomethanol. Biomethanol. Okay, now I explain what's the meaning of biomethanol. By microorganism fermentation of carbohydrates compound using, we can produce 100% renewable biodiesels, right? Biodiesel is the methyl ester of long carbon carboxylic chains, long chain of carboxylic acids. Yes, this is another name, just another name. Long R carbon, see, it has R carbon chain. They are the long chain of carboxylic acid. Carboxylic acid. Since the glycerol and methyl ester compound are immiscible, then the layer is separate. Therefore, these two regions can be easily separated. Okay, after this trans-esterification reaction, not like soap production. Not like soap production, these glycerol and biodiesel, two layers. They are separated. Methanol is polar, biodiesel produce biodiesel is the only oil, no? It's a type of fuel type. Therefore, it is non-polar. Non-polar and polar solvents always separating. Okay, I will show you later. Okay, but the next very important thing. Okay, now up to now what we discussed, what are the main raw materials in biodiesel production? Triglyceride and methanol, right? Triglyceride and methanol are the main raw material. And what is the main catalyst? Sodium hydroxide. What are the main product? Methyl ester of fatty acid, that means biodiesel and glycerol. Glycerol as byproduct. Glycerol as byproduct. Okay, the entire production process we called as trans-esterification. Trans-esterification. Okay, up to now we discussed the basic of biodiesel production. I told if we can get methanol from petroleum industry, it is not 100% renewable. If we can generate as a microorganism fermentation as biomethanol, we can produce 100% renewable biodiesel. Okay, that's a summary up to now. Okay, in the production of biodiesel, it's coming another error. Another problem. What do you think? What's the problem coming in the biodiesel production? If you go through this reaction, you can identify. For the production of biodiesel, the main raw material is a triglyceride, right? The main raw material is a triglyceride. The second raw material is a methanol, but as a catalyst, we are going to add sodium hydroxide or caustic soda adding as a catalyst. Then what do you think? It's coming error, it's coming problem. What do you think? Making issue, it's coming an issue. for biodiesel production reaction? Any idea? If we now just think, I have triglyceride container, right? I have to add methanol, CH3OH, methanol, and sodium hydroxide as catalyst. මෙතනදී issue එක මොකක් වෙයිද? My purpose to produce biodiesel, but additionally soap layer is forming. Why? This sodium hydroxide react with triglyceride. Understood? I got the issue. In this transesterification reaction, my purpose to produce biodiesel and glycerol as final product, but unnecessary reaction take place, unnecessary saponification reaction take place, because as raw materials I added caustic soda, as catalyst I added caustic soda. This caustic soda react with some part of triglyceride and it is converted into additional unnecessary soap layer. Understood? Udanya? Please respond. If you have any doubt, quickly info. No doubt, right? Tanya? Okay, that's the main issue. When we add methanol and sodium hydroxide both into transesterification reaction, part of sodium hydroxide react with triglyceride. Due to that, unnecessary soap layer is producing. This unnecessary soap layer is very it affect to the efficiency of biodiesel production, because some part of triglyceride used for unnecessary thing. Now soap මේකේ හැදෙන soap එක අපි use කරන්නේ නැහැ, it's unnecessary, no in use. Okay, in biodiesel, the problem can arise when sodium hydroxide is used as a catalyst. If there is too many carboxylic acid in the vegetable oil, whatever triglyceride, they will react with sodium hydroxide to form soap. That means unnecessary soap production, unnecessary saponification reaction take place in the reaction chamber. Due to the formation of soap, the catalytic action will be disturbed. Normally, catalyst mean, do you remember in kinetic chemistry lesson I explained, catalyst mean when we add any catalyst into whatever type of chemical reaction, catalyst cannot react with reactant, right? If it is react, it is not a catalyst. They can't do catalytic process. They can't speed up the reaction. Okay, it is a disturb for this catalytic process, and the production process will be disturbed. The production process, the efficiency will be decreasing, and due to the formation of this unnecessary soap layer. Understood, Dihini? Up to now, Udanya? Fatima? This unnecessary soap layer it's a disturb. Why? Due to this soap preparation, it's affecting the quality of biodiesel. Then we have to purify soap as well. It's a very disturb, and it is disturbed to the rate of reaction as well. It is not doing sodium hydroxide, not acting well as a catalyst. Therefore, it's affect to the rate of reaction as well. That's the most important thing. That's the most important thing. Okay, now our purpose, our purpose is decrease avoid this problem. We can't stop soap production. That's a true. That's a truly we can't stop soap production, but we can avoid. We can minimize the soap production. Okay. The amount of free carboxylic acid in vegetable oil, that means triglyceride, should be lower. If it is high carboxylic acid, free carboxylic acid, it's rapidly react with sodium hydroxide and produce soap. The saponification reaction take place easily. A measure of free carboxyl can be obtained by measuring the acid number. The measure of free carboxylic acid, free fatty acid actually. Free fatty acid amount in a triglyceride we can identify by the acid number of triglyceride. Acid number. Free fatty acid number කියලා කියනවා. Acid number කියලා කියනවා. හරිද? Acid number. Okay. It's not too advanced thing, very simple. Now, in trans-esterification, what are the raw materials? Triglyceride and methanol. As a catalyst, we use sodium hydroxide. When we use sodium hydroxide as catalyst, it's coming issue, but sodium hydroxide react with glycerol and produce additional unnecessary soap layer. To avoid this, to minimize this unnecessary soap layer, we can follow these methods. The first thing, we can minimize the acid value. Acid value means free carboxylic acid amount. Remember, the acid number is defined as the amount. That was a MCQ question. The acid number is defined as the amount of potassium hydroxide required to neutralize the free fatty acid percentage in vegetable oil or whatever triglyceride. That's very important. The potassium hydroxide is based on potassium hydroxide requirement to neutralize fatty acid amount, free fatty acid amount in vegetable oil. Remember, if it is less than 2.5, if it is below 2.5, free fatty acid number or fatty acid number, if it is less than 2.5, that is suitable for that we can use for biodiesel production. But if it is higher than, if it is greater than 2.5, acid value 2.5 if it is greater than 2.5, we have to careful, because if it is more than 2.5, it produces huge soap amount. But if it is less than 2.5, we can minimize soap production because very low amount of, because 97.5 not reacting, 2.5 විතරයි reacting. 2.5 reacting means very small soap production, very small amount of soap production. That's not that we can neglect. Okay. What are the treatment we can use to avoid soap production? The soap is unnecessary. The thing is, the first thing we can do, select triglyceride less than 2.5% acid number less than 2.5%. If it is more than 2.5%, we can first react methanol. Yeah, that's a option. If it is more than, if it is more than 2.5 now, if it is more than 2.5, first we can add methanol. First add methanol, right? Selam methanol down. First add methanol. Then mixing well. When it is reacted, half again reacted, we can introduce sodium hydroxide later. That's one option. By this method, we can avoid, we can minimize soap production, right? First react with methanol to convert free fatty acid into methyl ester. This pre-treatment step help reduce free fatty acid level and makes the oil stable for biodiesel production, right? That's a one option. First, we can add methanol, and when it is reacted, we can, if the free fatty acid amount getting lower, then we can add sodium hydroxide to increase the reaction process. Sodium hydroxide is a reactant. The purpose of adding sodium hydroxide increase the rate of chemical reaction. Make a speed up करने का तमाम purpose है. But additionally, it's coming problem. It's producing soap production. But that we can minimize if we can careful about the process. Careful about the process. Okay, up to now, okay. Okay. So there are 3 layers made in the production. Yes, if it is produced thick soap layer, it's producing 3 layers. It's an actually it is a waste. It's a waste of raw material, right? It's a raw material waste. Some part of triglyceride used to production of unnecessary soap layer. It's a wastage and increase a it's a huge problem actually. We have to we have to put effort to separate this soap again. We have to separate it, then it is affect to the quality of the biodiesel. It's coming as a foam layer. It's affect to the quality, and we have to put effort to purify this and remove this, right? And additionally, it is a wastage actually. In this, the soap layer we can't use because it's a small soap layer, but it is a wastage of our raw material because some part of triglyceride and sodium hydroxide used for this process, used for this soap saponification reaction. It's an unnecessary thing, but we can't stop this. We can't stop, but we can minimize if we can maintain the acid value. Acid value means free fatty acid amount, free fatty acid percentage. If we can maintain this free fatty acid percentage less than 2.5, the soap production is very minimum. There is small layer is producing that we can neglect. But if it is more than 2.5% acid value, it's producing thick soap layer. It's producing thick soap layer. It is affected our production process. To minimize that, what we can do? First add methanol. And when it is halfly reacted, we can introduce sodium hydroxide. Up to now, okay? Up to now, okay. Ranga? Okay, right? Tanya? To now understood? Hi. Sorry. Okay, when sodium hydroxide is used as catalyst, it is dissolved in methanol before the reaction. Yeah, this is another action. We can add sodium hydroxide, dissolve with methanol. Excess methanol is used to increase the yield of biodiesel. Yes, it's all. Yeah, that's not important. Har. Okay. Okay, that's a simple just idea. Okay, now I will show you and I will explain you how to produce biodiesel sample and how in large scale how to produce biodiesel step by steps. Okay, just I gave some idea. Now you have, I think now you have idea and issues coming in this process. Issues coming this process. Now I will show you step-by-step procedure of biodiesel production. In biodiesel production, the same methods actually. The same method, first we have to get triglyceride solution. That means oil solution. Think it is oil solution. The first thing, the oil solution heated. Same as soap production, right? heat the oil solution. That means triglyceride. Heat. The second step, if you want, you can note down when I explain. First step, heat the triglyceride. When it is heated, when this oil is heated, we can introduce methanol. Remember that if it is acid value, this triglyceride acid value less than 2.5%, without any issue, we can add sodium hydroxide and glycerol. Sodium hydroxide, not glycerol, sodium hydroxide and methanol. Okay, we can add methanol, CH. When it is heated, we can introduce CH3OH, that means methanol, CH3OH as a raw material, and as a catalyst, we can add sodium hydroxide to increase the rate of reaction, to rapid reaction, for the rapid reaction, increase the rate of chemical reaction as a catalyst. Okay. Normally, this sodium hydroxide we called, it is an aqueous solution, right? It is an aqueous solution. Sodium hydroxide is aqueous solution. Methanol also dissolved in water, aqueous solution. Now triglyceride is that one also we can say it is aqueous. Then what you think, sodium hydroxide homogeneous catalyst or heterogeneous catalyst? What do you think? Sodium hydroxide, caustic soda, homogeneous catalyst or heterogeneous catalyst? What do you think? Is it homogeneous catalyst or heterogeneous catalyst? Very important. Homogeneous catalyst or heterogeneous catalyst? In kinetic chemistry that we discussed, right? It's a homogeneous catalyst. Why? All reactants are reactant and catalyst in reactants are triglyceride and methanol, reactants and catalyst in the same physical state. Therefore, sodium hydroxide, caustic soda, aqueous solution we consider as homogeneous catalyst, right? That's the additional point. Now I have add methanol aqueous solution dissolved in water and sodium hydroxide methanol, sodium hydroxide aqueous solution into the heated triglyceride. Same as soap production, the third step is the stirring. First step heating, then add methanol and sodium hydroxide, then stir away. In the stirring process, in the mixing process, we can see it's producing, it's take place the trans-esterification reaction. It's producing biodiesel and it's forming a small soap layer as a form and it's producing glycerol. This glycerol and biodiesel not mixing because glycerol is a polar, biodiesel non-polar. They convert into separate layers. Okay, after this trans-esterification reaction, okay, this is the next step. Okay, now the trans-esterification reaction completed. Now can you suggest, can you imagine what are the materials contained in this solution after trans-esterification reaction? After reaction. මොනවද මේක තියෙනවා ඇත්තේ? After reaction. After trans-esterification, it's contain biodiesel, right? Some biodiesel. The next byproduct. What's the byproduct? Quickly. Pankara. Okay, now the trans-esterification is done. It's completed. Dihini? Nothing. It's, yes, glycerol is contained. Glycerol is as a byproduct. What else? remain in this solution? Fatima? What else remain? Unreacted oil, very good. Unreacted oil. But unreacted oil is no problem because biodiesel also oil ne. ඒක mix වෙලා තිබ්බට අවුලක් නැහැ. What else? What else? Unreacted methanol. Unreacted methanol is a problem. Unreacted methanol. Unreacted methanol is a problem. Unreacted methanol is contained. What else? What else? Samya? What else remains is this final solution? What else? Tanya? Yeah, Udanne. But one word wrong. Yeah, sodium hydroxide remaining, but it is not unreacted. Sodium hydroxide is catalyst. Catalyst එකක් කියන්නේ කොහොමත් react වෙන්නේ නැහැ. එයා ඉතුරු වෙන්න ඕනේ. Sodium hydroxide is, that means reactant. Sodium hydroxide is remaining. Good. Okay, this is the final solution now. This is the final solution. And it's contain water. Water dissolved in glycerol. Therefore, no problem. It's a aqueous solution, right? Hi. Now, if you need to use this biodiesel, if you need to get the final product, the thing I have to purify this. Purify this. I want to purify this, right? Pure karaganda. Okay, therefore this remain glycerol, remain mean byproduct of glycerol, and remain unreacted methanol, and so what catalyst we have to remove. Okay, let's see one by one step, one by one method, what we can do for remove these unnecessary materials. Now they are unnecessary. Our requirement to our it contains soap layer as well. No, soap also contain soap suthian. Soap thian. Okay, up to now okay. Send quickly message, Kabir. Tanya. Why, sir, unreactions happen? No, in chemical reaction, not all reactants are reacting. It has a, you can please go through or complete the ranga kinetic chemistry lesson. In kinetic chemistry lesson and thermochemistry, yeah, thermochemistry and kinetic chemistry both, we discussing about all reactants. These reactants are reacting according to the number of moles. Number of moles. If it is according to stoichiometry, methanol is greater than triglyceride, methanol is remaining. Methanol is remaining because additional amount remaining. Not always all reactants not completely reacted. Sometimes it's possible to make complete, but not always. Not always. Some remain amount is there, right? Remained amount, some small amount is remaining sometimes. Okay. Hari. Hari. After this trans-esterification, these are just simple trans-esterification reaction. After this trans-esterification reaction, it's producing biodiesel and as a byproduct glycerol and unreacted methanol. It has unreacted oil also, but that we don't need to consider because biodiesel it is mixed with biodiesel, therefore no issue. And sodium hydroxide catalyst normally catalyst cannot be react as a result of the reaction of catalyst. It is produced a small soap layer. Okay, that's a summary. Okay, now I'll show you. That was exam question many time in exam asked in the biodiesel production. What are the purification process? How to remove methanol? How to remove additional soap layer? How to remove unreacted methanol? And how to remove glycerol? Okay. Okay, see, it is clearly given here. After the trans-esterification, glycerol and specially produced glycerol and biodiesel, right? When it is produced, we can clearly see the two layer. That means lower layer is the glycerol because it is high dense, and upper layer is the biodiesel. Biodiesel is upper layer. It is same as soap production. The lower layer is the glycerol. Make a glycerol. And this is a biodiesel. Right? This is a biodiesel. These layers can be easily separate now. We don't need centrifugation because they are non-polar and polar solvent. Biodiesel is non-polar. Therefore, glycerol and they are the method. Gravity separation. We can gravity separate or centrifugation. It's a faster method. If you want a faster separate, we can use centrifugation. According to layers, we can separate glycerol and biodiesel. It's a simple thing. After separate these layers, this biodiesel part, residual soap, yes, I explained. Unreacted oil catalyst and unreacted methanol. Okay, they are the impurities. If you need PO, now this is a process. Okay, this is a glycerol. Clearly understand? This is a glycerol. And this is the remain thing means biodiesel and other impurities. Biodiesel plus impurities. Right? Biodiesel plus impurities. Okay, now it is clearly separate two layers. Therefore, gravity separation or centrifugation, we can separate the above layer. This above layer contain soap, unreacted oil, catalyst and unreacted methanol, right? It is not purified. The above layer is not purified. Okay. In the purification process, first we can remove methanol. Methanol is, remember, methanol same as ethanol. It is easily volatile. Yeah, volatile equipment. Easily volatile. Therefore, biodiesel we can slowly heat. If it is highly heated, biodiesel also evaporating, right? Slowly heating this biodiesel separated solution until evaporate methanol. Normally methanol we can collect in this methanol condense that we can again use for biodiesel production as a raw material. The evaporation methanol is condensed and recycled back to the production process, right? Okay, then how to remove this? methanol short note එකක් ගහගන්න. How to remove this unreacted methanol? By heating and evaporating. By heating and evaporation. Complete. Hari. First thing is done. Methanol is removed. Methanol is removed. Methanol is removed. Please draw this short note. That's very important. It is given in the tube, but better to draw this short note. This is a transesterification. This is a purification, right? Okay, let's see next one. Removal of glycerol and catalytic residuals. Catalytic residual mean sodium hydroxide, right? Sodium hydroxide. Okay, it's very simple separation that we can add water and wash out, or water bubbling. Water bubbling, that we call as water bubbling. Water washing is used to remove impurities. That means if we add water, normally think now it's contain normally sodium hydroxide and glycerol both. If there are any remain glycerol or sodium hydroxide, both dissolve in water. Therefore, without any problem, we can add water into solution by triglyceride not mixing with water. They are a separate layer. I got biodiesel and water is two separate layer. But if we can mix water and wash out, wash karama, this remains sodium hydroxide and mehema. That's the process. Think it is a beaker. This is a biodiesel layer. If we add water, water density is greater than biodiesel layer, water coming like this. Then we can wash out and separate this water layer. Then we can remove sodium hydroxide dissolved in this water. I got Tanya? Understood this separation? Unreacted catalyst, not unreacted, just catalysts are not reacted. Catalyst and remain glycerol we can separate by water washing by water. Hari. Then make it in glycerol and sodium hydroxide. Glycerol and sodium hydroxide washing by water or water bubbling. Washing by water. Not only that, soap also we can remove because soap also dissolved in water. Soap also dissolved in water. Okay, finally, biodiesel we can separate after water washing. Complete 100% purified biodiesel we can separate in this process, right? After that, biodiesel is dried to remove water. Yes, if there are any water particles, we can quickly dry. Actually, it's not compulsory. We can separate water. We can separate by filter method. Filtration to remove remaining solid particle. If there are any solid particle, we can filter by filters. That we can discuss later. I'll show you some video. Give me a second.
Today I'm going to show you how to make biodiesel using cooking oil, some fuel system cleaner, and a bit of lye. This diesel can be used in place of petroleum-based diesel fuel, but it's completely system phase that I really want to get rid of. At this point, some fuel system cleaner and a bit of lye. This diesel can be used in place of petroleum-based diesel fuel, but is completely sustainable and natural. Today I'm going to show you how to make biodiesel using cooking oil, some fuel system cleaner.
Okay, this is a simple biodiesel process in laboratory, but our steps and these steps can be changed, can be varied. I will show you if there are any change. I will explain. Okay. Carefully understand step-by-step process of biodiesel production, especially the purification process, because the transesterification thing is simple, and it's in the transesterification process coming issue that soap production that we can avoid, that one also okay. But the purification process, again exam questions, they deeply ask in this purification process. Therefore, carefully understand. This water washing is clearly shown in this video. Please see.
And a bit of lye. This diesel can be used in place of petroleum-based diesel fuel, but is completely sustainable and naturally sulfur-free. Now to get started, I simply pour about 500 milliliters of olive oil into a 1 liter beaker. Any oil will work here, but I accidentally bought gallons of olive oil during my soap making phase that I'd really like to get rid of. At this point, I turn on a
this is tire, simple style in laboratory.
Fuel additive. This specific fuel additive is nearly 100% methanol. Although methanol is preferred here, technically this process can be done using any alcohol with a minimal water content. Anyway, given that they're both fairly non-polar, the methanol will dissolve to some extent in the oil. They aren't entirely miscible though, so for the most part, this simply results in an emulsion of methanol and oil, which in my case turned a light yellow. I next added 5 grams of sodium hydroxide, which represents a significant excess. This excess was used partially to drive the reaction to completion, but also to try and sequester.
What he did, he just got triglyceride first, right? Triglyceride, then added methanol, aqueous methanol solution, and without dissolving he add, but we can add sodium hydroxide also. We can dissolve in water and add it to this, right? And styrene. They're doing heating process later, but in our discussion we did first heat the triglyceride and add it, right? In laboratory he doing in simple way, but in industrial it is different, right? Industrially large scale it is
sodium hydroxide lye, which represents a significant excess. This excess was used partially to drive the reaction to completion, but also to try and sequester any water that might be present. The beaker was then transferred to my hot plate and heated to around 80 degrees Celsius, at which point the reaction became active.
What is this yellow, white color particles? Is it biodiesel? Another white color, just like cotton. What are they? What are they? Yes, they are soap. That's why I told when we add sodium hydroxide as catalyst, it's producing unnecessary soap. It's unnecessary thing.
Thermic and heating was cut. At around 110 degrees Celsius, the temperature stopped climbing. And so at that point, heat was applied for the remainder of the reaction to maintain that temperature. Now, what's happening here is a two-step reaction that begins with a simple reaction between methanol and sodium hydroxide, forming sodium methoxide and water. The sodium methoxide then immediately begins to react with the oil in a type of reaction called a transesterification, which is very similar to the process used to make soap. Oils and fats are composed primarily of molecules called triglycerides, which are further composed of 3 fatty acids bound to glycerol. In this transesterification reaction, the sodium methoxide attacks the carbonyl here, forming an unstable tertiary intermediate. This intermediate then rearranges and subsequently collapses, displacing a methyl ester of the first fatty acid. In the final step, the glycerol backbone is protonated by the water molecule produced during the formation of the sodium methoxide, and the process repeats. This continues until all three fatty acids have been converted to their methyl esters, and the glycerol backbone is liberated as free glycerin. Since hydroxide is regenerated in the final step of the reaction, the sodium hydroxide essentially acts as an esterification catalyst. And this is why the 5 grams were a fairly large.
You don't need them.
And by using
They
less,
won't
you
make a
might
jump.
not need to go through the extra step of removing it later. As a side note, I came up with this procedure entirely on my own, and if I was going to do it again, there's one thing I might try differently. That is, instead of directly adding granulated sodium hydroxide, I might try dissolving the sodium
Now, the
hydroxide.
transesterification is done. After that, they're doing purification process, right?
In the methanol first using a bit of heat, and then add that to the oil. I feel like doing it this way would help the reaction go to completion a lot faster, but it might result in an ultra.
Yeah, they're doing first filtering process. Filtering,
which could be more difficult
because some solid
anyway,
soap
as the
particles.
proceeds, the mixture becomes increasingly dark and eventually clears up. A lot of little bubbles are produced early on, which I suspect is due to unreacted methanol trying to evaporate. After about 30 minutes of reacting, I felt nothing more was happening. And so I took the beaker off the heat and passed the crude biodiesel through my Buchner funnel to remove all of the excess hydroxide. This was then transferred to a
funnel is a special type that we call as separation funnel. Buchner funnel. Separation funnel see, separatory funnel. Okay. Now they are trying to, after filtration of these soap particles, they are trying to separate glycerol, see?
Funnel, at which point I left it overnight to allow the more polar and very dense glycerol to settle to the bottom. When I came back the next day,
see, these dark color things are the glycerol. That's why I told, due to polar and non-polar, it is with time it is easily separated. Up here, they're going to make a funnel using this valve. We can separate.
The process of cleaning up the crude biodiesel. Unfortunately, I quickly found that the glycerol had solidified.
This is a glycerol, right?
I suspect this is mostly due to the fact that the glycerol layer likely contains all of the water-insoluble impurities that were in the oil. It's also probably due to the glycerol soak with any water that was hanging around and some unreacted triglycerides. Regardless, I went ahead and just decanted off my crude biodiesel layer and rinsed the glycerol soaked mess
completely biodiesel, right?
Once it was nice and clean, I returned to the biodiesel for the separatory funnel along with 400 milliliters of water. I gave this a vigorous shake.
This is a water washing process. I explained about water washing process or water bubbling process, right? After the ice steps, what we did, first I separated the glycerol by the separation funnel. Using a separation funnel, it's easily separate. It's easily 2 layers we can separately identify. Then the lower layer we can remove lower layer. After that, we can add water and doing water washing process. During this water washing process, remain soap and remain catalyst sodium hydroxide and remain unreacted remain glycerol. Everything we can dissolve in this water, and easily water layer we can separate by because polar and non-polar separation.
Out of my separatory funnel. Once it was nice and clean, I returned the biodiesel to the separatory funnel along with 400 milliliters of water. See, I gave this a vigorous
the water layer come into lower layer. Why? Water density greater than biodiesel. Biodiesel is low
allow the aqueous layer to settle to the bottom. This step will help wash away any soaks or unreacted hydroxide from the biodiesel.
Now you can see water is this all glycerol, sodium hydroxide, everything dissolved in the water. Now we can separate the
couldn't really be unreacted oil present as any fatty acids that didn't convert to biodiesel simply became part of the system. Anyway, the rinsing step is repeated 2 more times until the aqueous layer is completely clear and the layers separate very quickly due to removal of any surfactants. The biodiesel is next drained into a flask, and at this point, the
separate the biodiesel.
Impurity is water. The water can obviously be removed by boiling, but because I felt that was unnecessarily dangerous, I instead dumped in a few grams of anhydrous sodium sulfate and gave the flask a hard shake. This was again left overnight, during which time the sodium sulfate completely absorbed any water that was present in the biodiesel. This was then passed through my Buchner funnel one final time.
Yeah, finally it is filtering if there are any solid particle. This chemical, they're doing a chemical process for remove biodiesel. Remove water from biodiesel. If there are any water particle remain, they're doing chemical process, but that is not given in our syllabus. After that, finally, we can filter out the solid particles. That's the final step.
Biodiesel. I forgot to weigh my final yield, but as you can see here, I produced just enough to perfectly fill up this 16-ounce mason jar. Now, here I have 3 test tubes. The first contains unprocessed olive oil, the second contains a sample of my undried and unfiltered biodiesel, and the third contains my pure final product. As you can see, the biodiesel looks very similar to the oil, but it's distinctly lighter and contains none of the slight green hue that olive oil has.
Yes, he explained
the biodiesel also
biodiesel color. Biodiesel color, it is similar to olive oil. That's it.
It's roughly the same density as oil, but it's significantly less viscous, as you can see when I shake the test tube. As a final demo, I decided to test how the biodiesel performed as a fuel compared to straight olive oil. To do this, I simply saturated 2 cotton balls, one with olive oil and the other with the biodiesel. I then ignited the biodiesel-soaked cotton ball, and after some difficulty, I did the same with the olive oil-soaked ball. As you can see, the biodiesel is dramatically more flammable than the oil, and produces
biodiesel is flammable,
but over a much longer
but olive oil, just oil is not flammable.
Black soot as they burn, but
yeah, they are simple things.
Behind dramatically more residue than the biodiesel by the time it finished burning. As I said earlier, this biodiesel can be used in place of petroleum diesel, and it's certainly a good potential use for old cooking oil. If there's enough interest, I might consider following this video up by contacting a local restaurant to see if they'll give me their waste fry oil, so I can try and optimize this process on a multi-gallon scale.
This is story. I think you got the full story, right? Do you have any doubt? Now you can ask. Any doubt? Do you have any doubt? Dini? Hari. Tanya, clear, right? Fatima, Kabir, Sharon, everyone clear? Hari. Okay. Now I told in the production process, we use a homogeneous catalyst. We use a sodium hydroxide, no? Caustic soda as homogeneous catalyst. But apart from sodium hydroxide homogeneous catalyst, we can use heterogeneous catalyst as well. But if you use heterogeneous catalyst, the reaction, like homogeneous catalyst, not increase the rate of reaction, but we can use, right? The reason we can avoid soap production. The heterogeneous catalysts are magnesium oxide and zinc oxide. Remember, make a halathina exam. Magnesium hydroxide and zinc oxide. Sorry, magnesium oxide, not hydroxide. Magnesium oxide and zinc oxide we can use as heterogeneous catalyst, just powder, as powder. Then we can avoid, minimize soap production. Not, we can't stop, we can minimize. Advantage, it's reduce soap production. Improve the efficiency. Soap production reducing mean efficiency increasing. Minimize environment issues. Yes. Because soap is a waste thing. Okay. Can anyone send me what is the main disadvantage of biodiesel, usage of biodiesel instead of petroleum diesel? What is the main disadvantage? මොකද්ද මේකේ තියෙන අවාසි? Fatima, what's the main disadvantage of biodiesel? Now it has a lot of advantage. It is renewable and that is environment friendly. Lot of advantage, but it has a special disadvantage. What is this? Very common disadvantage. That's the reason it is not popular yet. Udanya? Normally in Sri Lankan condition, we not producing at least 1% biodiesel. At least 1 liter. We only doing for laboratory purposes. What's the reason? Why in practically we can't use biodiesel production? It has a reason, specific reason. Kabir? Think. Tania? Sarmia? Dini? What is the practical issue? Very good, Seva. Say no. Perfect. Very good to that. The thing is, what are the raw materials we used? As raw materials, we use oil. How about the price of oil? It is more than 700, no? 1 liter? More than 700, 800. Normally petroleum than diesel අපි දැන් නම් කීයද දන්නේ නැහැ වැඩි වෙලා නැතිනේ. Normal petroleum diesel අපි කියමු 300 කියලා. 300 rupees. If you got biodiesel liter, it is more than 1000. That's the main problem. It is expensive due to the production cost. Due to production cost, we can't add filling materials. We can't add filling materials. Therefore, it's more expensive due to the production process and raw materials. But petroleum diesels, we can get in 300, around 300 rupees. That's the main issue. That's the main barrier for biodiesel production. That's the main barrier. That's why in entire world, it is not popular yet. It's expensive thing. And the production process also expensive. Not like in petroleum diesel, we only doing purification process. But in biodiesel, we have full chemical reaction, transesterification. It's expensive. The raw materials as well as production process, both expensive. Therefore, final product also, it has high value. That's the main issue. Therefore, biodiesel is widely used as an alternative fuel. But the thing is, due to this price, in the world, 100% purified B100 biodiesel. B100 means 100% biodiesel. මේක use කරන්න නැති තරම් ඇත්තට. Use කරන්න නැත්තර. It's very rare to use. But B20, some countries use B20, B5, B2 biodiesel types. That means actually B20 means 20% biodiesel mixed with 80% normal petroleum diesel. B5 means 5% biodiesel and 95% petroleum diesel, right? Petroleum diesel. 2% means only 2% biodiesel, remain 98% is petroleum diesel, right? Understood? Okay, that's the story. Sometimes this 2% also, it's a considerable value. Think country ekaka, our normal in Sri Lanka, normal daily consumption, I think normal fuels measured by kiloliters. Kiloliters 4,000 kiloliters. That means liters වලින් ගත්තොත් 40 lakhs. 40 lakhs. If we can replace 2%, it is 80,000 liters. We can minimize petroleum diesel use in 80,000 liters from 40 lakhs. That one also considerable value. Therefore, normally, if we can use 20%, that's perfect. But the thing is, if we use 20%, it take increase the price, diesel price. Okay, they are the main issue. Okay, that's the end of biodiesel production. B2, B5 types, some countries use. They have doing as a pilot project. Actually, entire country they not going to use, but as a pilot project, they trying to do this. 5% biodiesel and 95% petroleum diesel mix using as a mixed solution. Then we can minimize petroleum production, diesel consumption, right? And B2, 2% biodiesel and 98% petroleum diesel. Okay, if you have any doubt, now you can ask related to biodiesel production. Completely discussed today, biodiesel production. And soap production and other oil productions we can discuss complete next day. Yesterday we missed our revision. No? Are you free Friday? Friday, do we have class? Friday, same time, evening? Salmia? Joel? Okay. Okay, before let's do revision next week. Let's do the remain part of this lesson. If we complete this industry chemistry and natural product lesson, it is easy to continue our works. Okay, therefore, Friday, let's try to complete industry chemistry. Okay, Friday, let's take 3 hours. If you got 3 hours, we can complete. We have only 3 productions. They are very simple. Milk productions, phosphate fertilizer, paint production. Yeah, we can complete. Therefore, don't miss Friday class. Friday, I'm going to discuss 3 productions: paint production, phosphate fertilizer production, and paint production, and complete industry chemistry lesson. The thing this week before Friday, that means tomorrow itself, you have a special work. You have to prepare short note for soap production and biodiesel production, similarities and differences. What are the raw materials of soap production? What is the chemical name of soap production? What is the byproduct of soap production? What are the main product chemical name of soap production? Everything get into 2 papers: soap production and biodiesel production. Compulsory. It is very important because making is a compulsory coming essay question from this biodiesel production and soap production, right? Therefore, please make 2 short notes, clearly mention all steps and important points, right? That's your homework. And let's meet Friday evening with the final part of the lesson. Good night.